Today I want to talk to you about being smart about choosing the right technique to solve your quadratic equation. We've spent a lot of time with this four-step plan to solve equations, and maybe you think that this is always the best way to solve an equation, and actually it's not. Sometimes there are other tricks we've learned before and that we can still use. So for example, how would you solve this? X squared equals 16. Now if you would follow this four-step plan, then you would say, oh, the right hand side should be 0. Oh, so I need to subtract 16 here from both sides, of course. X squared minus 16 is 0. Now I have to factorize the left hand side, so I have to do this using the sum product method because these factors don't have anything in common. So I'm looking for two numbers whose sum is 0 and whose product is negative 16, so that will be 4 and negative 4. So I can factorize this as x minus 4 times x plus 4. So now I factorized it, and now I can say this is a product of two factors. The result is 0. So one of these two factors has got to be 0. So x minus 4 is 0, or x plus 4 is 0. And that means that solving these linear equations, that means that x is 4 or x is negative 4. And this gives us the right solution, but it's a bit tiresome, of course, because we also just know that if some number squared is 16, well, then that number has to be the square root of 16 or negative the square root of 16. In other words, we can just immediately go from this equation to the solution x is 4 or x is negative 4. So if you want to be able to do this fast, you always want to be able to identify for each equation what technique is going to work best for solving this, and that is what this video is about. And basically, so far we have seen three types of cases, and I'll deal with them first in general, and then we will see examples of all of them. The first case is where our equation has terms with only x squared in it and maybe numbers. And that means that we can basically do the trick that we just saw. We can say, oh, that means I can write it as x squared is some number, and then x itself will be the square root of that number or negative the square root of that number. That's the first case. The other two cases are the cases we've dealt with in the previous videos. The second case is that our equation has only terms with x squared or an x in them. That means that all terms have an x in them, and that means that if I bring them all to one side, so I make the right hand side 0 and bring all my terms to the left hand side, then I will be able to factorize the left hand side by taking out a factor x. So that's the second case. And the third case is where I have terms with x squared and x and with numbers. So when I simplify everything and bring it all to one side, I still have three terms left. And that is when we will have to use the sum product method. So again, we make the right hand side 0 and we factorize the left hand side, in this case, using the sum product method. So based on what my equations look like, I will hopefully be able to identify which of these techniques I am going to use. So let's look at a few examples and first see what technique are we going to use, and then see that actually in practice. So first example, 2x squared equals 50. So I have a term here with x squared, and I have a term with just a number and no variables at all, no x and no x squared. So which case is this? This will be a case 1. We have only terms with x squared or numbers. So then it says we can rewrite this to x squared is some number. So we're going to go from this to x squared to just x squared. So that means we divide by 2, and that means we also divide the right hand side by 2. So we get x squared equals 25. X itself will be the square root of 25 or minus the square root of 25. So it will be 5 or negative 5. Let's look at another example. 4x squared equals 12x. So I have a term here that has x squared and a term here that has an x. So this is a case 2 situation. And what it says here is, in that case, we're going to make the right hand side 0, and we can factorize the left hand side by taking out a factor x. So let's do that. How do we make the right hand side 0? We have to subtract 12x. So we have to do that on both sides. So we get 4x squared minus 12x equals 0. Now both of these terms have an x that we can factor out. We can actually factor out 4x. Doesn't really matter whether you factor out just the x or 4x. 4x makes it slightly easier in the next step. So we factor out 4x. 4x squared minus 12x becomes 4x times x minus 3 is 0. And now we go on, as we're used to, by using the a times b is 0 rule. That means that either this factor is 0, 4x is 0, or x minus 3 is 0. This gives us two small equations. If 4x is 0, then x is 0. And if x minus 3 is 0, then x is 3. So this is our solution. Third example, here we have a term with x squared, a term with an x, and a number. So that's case 3. So then we're going to make the right-hand side 0 and factorize the left-hand side using the sum product method. So we have to subtract 2 from the right-hand side. We have to do that on both sides to keep the equation balanced. So we get x squared minus x minus 2 is 0. Now we have to use the sum product method to factorize. We're going to look for two numbers whose sum is negative 1. There's a secret 1 here. Sum is negative 1, and the product is negative 2. And those numbers will be negative 2 and positive 1. Negative 2 plus 1 is negative 1, and negative 2 times 1 is negative 2. So we factorize this as x minus 2 times x plus 1. Now this times this is 0, so this is 0 or this is 0. So x minus 2 is 0 or x plus 1 is 0. And we can solve these small linear equations. This gives us x equals 2, and this gives us x equals minus 1 or negative 1. Another example, here we see a term with x squared, any term with just a number. So this is a case 1 situation, only terms with x squared or numbers. So we are going to rewrite this to x squared is some number. How do we do that? In this case, we have to go from negative 4x squared to just x squared. So we divide by negative 4. So the left-hand side becomes x squared, and the right-hand side becomes negative 12 divided by negative 4 is 3. So we get x squared is 3. If x squared is 3, then x is going to be the square root of 3 or minus the square root of 3. And we can't simplify this any further, so this is our solution. And of course, this is also a solution that we wouldn't have been able to, probably wouldn't have been able to find using the sum product method, because we are used to using that only for integers. Another example that shows that we have to keep thinking even when we have these different scenarios. We can, of course, simplify all of this by multiplying out the brackets, but let's not do this. Let's remember that we already have the form a times b equals 0 here. So that means we just immediately go to the step where we say, oh, that means x minus 5 is 0 or 2x plus 3 is 0. And it gives us two linear equations. This gives us x is 5, and this gives us 2x plus 3 is 0. So subtracting 3 on both sides, 2x is negative 3, and then dividing by 2, x is negative 1.5. Final example, x squared minus 5x plus 4 is 0. We have terms with x squared, x, and a number, so we're going to use the sum product method, looking for two numbers whose sum is negative 5 and whose product is 4. The product is positive, but the sum is negative, so this will be two negative numbers. And the numbers we're looking for will be negative 4 and negative 1. Negative 4 plus negative 1 is negative 5, and negative 4 times negative 1 is positive 4. So the numbers are negative 4, negative 1. We factorize this as x minus 4 times x minus 1 is 0. And now we can move to saying that means that this is 0 or this is 0. So x minus 4 is 0 or x minus 1 is 0. So that means that x is 4 or x is 1. So long story short, keep thinking, and especially when you see an equation, first think which technique am I going to use to solve this, and only then actually start solving it.